Welcome to today's episode of Tech Talk, where we dive deep into the cutting-edge world of 3D graphics and game development. I'm your host, and today we're exploring a fascinating topic: dynamic level of detail, or LOD, using mesh optimization techniques similar to Epic Games' revolutionary nanite technology featured in Unreal Engine 5. So let's set the stage. Have you ever been engrossed in a game where the environments were breathtakingly detailed, yet the experience remains smooth, even during intense action? Well, that's where dynamic LOD comes into play. It's a technique that allows for real-time detail adjustments based on the viewer's perspective, optimizing performance while maintaining visual fidelity. Now, I recently came across a project that ambitiously attempts to reproduce a dynamic LOD using a library called threejs. While it admits to being far from perfect, it is an intriguing start. Picture this. The process begins with clustering a complex mesh into smaller, manageable pieces called meshlets. It's like breaking down a big puzzle into smaller chunks. Much easier to work with, right? These meshlets are then grouped into adjacent clusters. This step is critical because it ensures that related pieces are handled together, reducing rendering overhead. Think of it like organizing your notes before an exam. Having related information at your fingertips can make a world of difference. Then comes merging. It sounds technical, but essentially it's about sharing vertices between these meshlets, a bit of collaboration happening in the 3D space. After that, there's mesh simplification, where they aim to reduce the number of triangles to keep things light on the GPU. Imagine having a super detailed painting, but choosing to switch it to a simplified version when viewed from afar. The detail is still there when you get closer. Lastly, it splits these meshes into smaller parts, aiming for optimal performance, which, in essence, keeps the frame rates up and the graphics fluid. Now, I can't help but wonder, how do developers strike the right balance between detail and performance? It's a question that many in the gaming industry wrestle with. If you think about it, having a jaw-dropping landscape is great, but if it causes your game to lag, that's where players draw the line. This project also references some heavy-hitting techniques from the scholarly world, including streaming, occlusion, and batch triangulations. These are critical in ensuring that even when dealing with very large datasets, think sprawling open worlds in popular games, it can handle real-time rendering seamlessly. Before we wrap up, let's consider the next steps for this project. It mentions that further testing on different levels of detail and a concept called DAG cut is on the horizon. I know, lots of jargon, huh? DAG, or directed acyclic graphs, can be incredibly powerful for managing and rendering complex data structures efficiently. But what it really boils down to is the promise of even more optimized graphics that could lead to photons flying off the screen in ways we haven't imagined before. To summarize, today's conversation has ventured into the realm of dynamic LODs and the relentless pursuit of optimizing 3D graphics in real time. We've touched upon mesh clustering, merging, simplification, and the role of advanced algorithms in enhancing our gaming experiences. I hope you've enjoyed this deep dive as much as I have. If you have any thoughts or experiences with dynamic LOD technologies in games, I'd love to hear from you. Until next time, keep questioning and exploring the tech that shapes our digital lives.